All right, solving simple systems by substitution. Graphing method works well when you have really simple graphs and when you have really nice xy's that fall without fractions. All right. But if you have more difficult ones, then it's often easier to use another method. The next method we're going to talk about is substitution. Basically, with substitution, you are going to want a variable by itself and you're just going to put it in its place in the other equation. Think of anyone who plays a sport. When you substitute in, you substitute player for player. Okay, so volleyball players, you know how it is. We substitute, right, player for player. One comes out, one comes in. You just take the place of. Same concept mathematically. All right, we have something that equals one thing. We put that into the place in the other equation for that exact variable. All right, so let's look at the first example. The first example, they actually have a variable all by itself for us. All right, you'll see that we have the first equation, x plus y equals 5. And then we have the second equation, y equals negative 3x plus 7. We already have a variable that is all by itself, this y right here. When this happens, we can go straight to substituting. What I mean by that is we can now take what that y equals and we can substitute it into the other equation for that variable y. So I'm going to rewrite my x plus y equals 5, but instead of writing a y, I'm going to write what y equaled from the other equation. Y equals negative 3x plus 7. So x plus y equals 5. This is my x, this is my y, and I used the other equation to plug it in, equals 5. X plus y equals 5. I substituted in, I replaced y with what y equals from the other equation. And then I'm just going to solve this guy. So I have x, it's just a 1, right? Technically, I'm distributing to get it out of the parentheses, but when it's a 1, it actually doesn't affect anything. 1 times negative 3x, that's a negative 3x. 1 times 7 equals 5. I'm going to combine my like terms. A 1x and a negative 3x give me a negative 2x plus 7 equals 5. And then I'm just going to solve. Subtract my 7. Those cancel. I get negative 2x equals negative 2. And then divide by negative 2. I have x equals 1. This is a systems of equations, which means I will always have an xy answer. Just like when I graphed, my answer was some x and some y. This will be true for these as well. I already have my x value. To find my y, I just need to plug it back in. You can actually plug it into either one of them. It doesn't matter. If I plug it into this, what y equals negative 3 times x plus 7. So y equals negative 3 plus 7, y equals 4. Or if I plug it into the other one, x plus y equals 5. X, I knew it was 1, plus y equals 5. Subtract 1, y equals 4. You'll see I get the same answer, no matter which one I plug it in. That's fine. But my final answer should be an x, y value. 1, 4 is my answer. So in this case, neither one has a variable by itself, completely by itself. So I want to get one of the equations with a variable completely by itself. It does not matter which one. I just usually choose the easiest one, okay? So like for this one, I would probably take this second equation and get the x by itself. So I would take the x minus y equals 10, and I would add y to both sides. And that would leave x equals y plus 10. All right, so I just took that second equation and I got a variable alone. And now I can substitute that into the first equation. So whatever equation I used, I'm going to take that and plug it into the other one. So I'm going to take this and plug it into this first one for that x. X equals y plus 10. So that's what I'm going to substitute in. So now I'm going to take my x plus y equals negative 4, and I'm going to replace the x with what I just said x equals. So I'm going to say y plus 10, that's my x, plus y equals negative 4. All right? It's a 1 in front of it again, so the parentheses are really insignificant. So I combine my like terms, 1y and 1y, that's going to give me 2y. All right. And then I'm going to have plus 10 equals negative 4, right? And then I will subtract my 10 over. Two y equals negative 14. And then I am going to divide both sides by 2. Y equals negative 7. Again, I'm not done. I need an x and a y. I can choose either of my equations. So if I take the first one, x plus y equals negative 4, plug my y in for that. X plus negative 7 equals negative 4. And then I'm going to add that 7 to both sides. It's a negative 7. X equals 3. So my answer here is going to be my xy, my xy. And I can check it. 3 plus, right here, 3 plus negative 7 equals negative 4. That is true. 3 minus a negative 7, or 3 plus 7 equals 10. That is also true. So if I plug it back into both equations, they will both be true statements. Okay? How do I solve by substitution? Solve either equation for either variable. It doesn't matter as long as one of your equations has a variable all by itself. Substitute the solution of that into the other equation for the variable, then solve. You will have only solved for one of your variables, so then use that variable to solve for the other one. Write the solution as an ordered pair, x, y, and then you can check your solution by substituting those numbers into your original equations, and it should be a true statement. Okay? So let's look at example 3 right here. Solve the system. So when I look at this one here, x minus 4y equals 0, and 3x plus 2y equals 8. Which of those four, x, negative 4y, 3x, positive 2y, is easiest to get completely by itself? Getting this by itself is easier than anything else because it has a 1 in front of it. In order for me to get this by itself, I would have to eventually divide by negative 4. In order to get this by itself, I would have to divide by a 3 at some point and get some fractions in there. In order to get this by itself, I would have to divide by a 2. So for these two equations and those variables, I'm going to use the first equation, the x minus 4y equals 0, and I am going to get specifically that x by itself. I'll move the 4y over, and I will get x equals 4y. That was the easiest to get by itself. And now I'm going to rewrite this equation, plugging in a 4y for x. So this equation is 3x plus 2y equals 8. 3, and instead of x, I'm going to use what I just solved for. 3x plus 2y equals 8. And now I'm just going to solve my equation. 3 times 4, we have 12y plus 2y equals 8. I have 14y equals 8. I have y equals 8 over 14, which reduces to 4/7. So I have my y. All right. If I want to solve for my x, I can just plug it in right here. X equals 4 times y. Y was 4/7. Remember, that's 4 over 1. So x is 16/7. And now I have my x and my y. That would be a horrible one to solve by graphing. Yes? There's no way you're going to estimate 4/7, right? Maybe estimate 1/2 if you saw that, but you probably would not estimate 4/7, okay? So this is a situation where I would definitely say I'm not going to solve that one by graphing. That's going to be a hard one. So 16/7, 4/7. First of all, your solution should always be an ordered pair. That is true for this whole chapter. Whether you're solving by graphing, the way that you find the solution is to graph, but your answer is x comma y. Okay, it is a point. If you're solving by substitution, you're going to get one variable. Don't stop. Go back and find your second one because it should always be an xy as your answer. Solve either equation for either variable. It does not matter. You can solve for x, you can solve for y, you can get x by itself, get y by itself. But the path of least resistance is what we're looking for, okay? If you already have a variable that has a 1 coefficient, 1x, 1y, get that one by itself. Don't get the one that has like 3x in front of it and it's going to cause a fraction. You can solve it that way. You'll actually get the same answer, but you'll have to use fractions the whole time to do it, right? Which is not anyone's preference usually, okay? So path of least resistance is what we're looking for. Easiest variable to get by itself. That's your first step. And then take that whole group and plug it into the other equation that you haven't used yet. And then solve for that one variable, okay? Let's look at a word problem. Brian has 84 feet of fencing, wishes to fence a rectangular area so that the length is 6 feet longer than the width. Find the dimensions, okay? So anytime I see the word rectangle, I'm probably going to sketch it just to get an idea, all right? So when I have a rectangle, I have length times width. And a key word here is fencing. Fencing means the distance around. Another way to write that is perimeter, right? Perimeter, okay? So how much fencing I have is my perimeter. I have 84 feet of fencing, okay? 84 feet of fencing, which means my perimeter is 84 feet. So I'm going to write an equation for perimeter. 2 times my length plus 2 times my width should equal my perimeter of 84 feet, right? That's basic perimeter for a rectangle, all right? Then they give us a second part of this. The length is 6 feet longer than the width. Length is, how do I write 6 feet longer than width? Yeah, so I have my width and I'm going to add 6 to it, right? 6 plus my W. So how do I solve for this? Well, it's already set up for substitution, isn't it? I already have a variable by itself. I'm going to plug it in to the other equation. So I'm going to say 2 times L plus, no. Plug it in here. There we go. So I'm going to say 2 times L, and instead of L, I'm going to write W plus 6 plus 2 times W equals 84. And I have an equation that I can solve. Distribute 2W plus 2 times 6 is 12. Combine my like terms, 2W and 2W. And then we're just down to solving. Subtract my 12. 4W equals 72. Divide by 4. W equals 18. I have found one of them, right? I found this. Specifically, it is 18 feet. To find my L, what do I need to do to my W? Add 6, right? It's 6 feet longer. So this is going to be 18 plus 6. This is going to be 24 feet. So I have solved for my dimensions, all right? They've given me 2 things to help me solve my dimensions. They've given me the perimeter by saying fencing, and then they've told me that my length is 6 feet longer than my width. It is a basic substitution. It already has a variable set aside for you. So this says two numbers total 996. Do I know the two numbers? No, I need variables. You could have used X and Y for all it matters. But when I add them up, I get 996. That's what it told me, right? That's my first equation. The difference, that should immediately make you think subtraction. Difference of the larger L. I just did L for larger. You could have done, like I said, X and Y. And twice the smaller. Well, that's 2 times S. So the difference between larger L and 2 times the smaller, 2S, is 33. I have 2 equations, right? I need to set one variable by itself. I chose this one only because I would have had a subtraction over here that I would have used with that one. And so I just moved that guy over. I moved this one over. It avoided any distribution, right? So I just moved the 2S over. L is a positive 2S plus 33. Remember, when it goes across the equal sign, it changes signs. So I changed this guy and set the L by itself. And then I'm taking now my other equation that I haven't used yet, L plus S equals 996, and I'm plugging in this for L. So instead of L, I wrote 2S plus 33 plus S equals 996. Combine my like terms, 3S plus 33 equals that. Subtract the 33, 3S equals 963, beautifully divided by 3, right? So I got 321. 9 divided by 3, 6 divided by 3, 3 divided by 3, right? 321. If I know they add up to 996, I just subtract from 996 to get my second number, 675. Those are my 2 numbers. Do they work? Well, I can check it. First, do they add up to 996? Yeah. If I add 675 and 321, they add up to 996. If I take 675 and subtract 2 times 321, do I get 33? Yeah. If I do 675 minus 642, I get 33. Right? So I can check it based on my equations. See, does it make sense for what it told me those 2 numbers should do? It does. All right?